A vertical pole is to be supported by a wire that is 26 feet long and anchored 24 feet from the base of the pole. How far up the pole should the wire be attached? Well, this problem, it's probably a good idea to draw a picture of what we're looking at. So here's our vertical pole, and it's to be supported by a wire that's 26 feet long. So here's the wire. It's 26 feet long. And that wire is anchored 24 feet from the base of the pole. So it's 24 feet in the horizontal distance. This can be represented by a right triangle. So notice in this right triangle, the missing piece is the vertical pole, which is X. So we're going to do some steps here, starting with step 1. Where we're going to identify any unknown quantities. So X is our unknown quantity, and we'll let X equal the height on the pole at which we should attach this wire. Okay, now we're ready for step 2. Normally, in step 2, we let any other unknown quantities be defined in terms of X. But in this case, we can skip step 2 because there are no other unknown quantities in our triangle. So we'll go ahead and move on to step 3. In step 3, we write an equation relating the unknown quantities. Well, it's a right triangle, so we'll use the Pythagorean theorem. In this case, we have x squared plus 24 squared is equal to 26 squared. Remember, the sum of the squares of the legs is equal to the square of the hypotenuse. And now we're ready to solve this equation. So in step 4, we'll solve, and we'll get x squared plus 24 squared, which is 576, equals 26 squared, which is 676. If we subtract 576 from both sides, we get x squared is equal to 100, or x is equal to 10. We'll only take the positive square root because remember, x represents a distance. So we're ready to state our answer now. The answer is that the wire should be attached at a height of 10 feet on the pole. And in step 5, we can check our answer by substituting 10 in for x, and we can see that 10 squared plus 24 squared is equal to 26 squared, and this checks.